Hello and welcome to this podcast for ElectroPages. I'm your host, Robin Mitchell, and in the next few podcasts you're going to be watching, we are currently covering the Public Tech event, which is being held in Munich, where we've had the opportunity to speak to some pretty cool companies, and today we're going to be speaking to u-blox. So without further ado, please tell the audience who you are, what you do, and what we're going to be discussing today.
Sure, thank you for having me. My name is Sabrina Bochen. I am the Director of Product Planning and Marketing for u-blox Cellular Products. u-blox is a module and chip maker based in Switzerland. We have a number of different products that we make in our lineup, ranging from GNSS products to cellular modules and short range, including Wi-Fi and Bluetooth, along with some services that we use to enhance those products.
And more importantly, what do you like to do in your free time?
What I like to do in my free time, I like to run, ski, yoga, those types of things.
We talked to somebody else who also had similar interests, to which I then had to retort with, I like to sit on couches all day and not move at all, as I am probably one of the world's most laziest people. But so quite a bit of a difference there. Now u-blox, actually I didn't realise it was a Swiss-based company. I thought it was German.
Yeah, we're based right outside of Zurich, actually.
Oh, right, because I will say this. I know we're supposed to be unbiased, but I will say I do love u-blox products. They are absolutely fantastic. So, you got a big fan right here, over here. But yeah, I didn't realise it was Swiss. I thought it was, I swear to God, I thought it was German or American. So you learn something every day. So,
well, now you know.
Absolutely. So, it looks like today that you're releasing a new module. So could you tell us a bit about what's going on?
Yeah, so we're really happy to be able to announce today the Sera S528N M10. It is our first IoT NTN module. So what IoT NTN means is essentially connectivity to non-terrestrial networks. And so the new Sera module, this S528, supports cellular connectivity via LTE-M and NB-IoT. But then if you're in an area where maybe you're out of cellular range, you can connect to satellite as well, and your device does not lose connection.
So what kind of satellites are we talking about in terms of non-terrestrial communication? What kind of bands? That's sort of technical details.
Yeah, so IoT NTN is a standard that was put forth by 3GPP, which is the international body that standardizes cellular technology. And whenever they put new standards forth, they do this in releases. So a little while ago, there was something called Release 17, and as part of that release, IoT NTN was included. So that's IoT non-terrestrial networks. And so what this does essentially is define how terrestrial networks, meaning cellular networks, can operate with satellites. And in this case specifically, there's kind of two different types of satellite orbits to consider. There's GEO, which stands for geostationary satellites. They're quite high altitude, and LEO satellites, low Earth orbit satellites, which are a little bit lower altitude satellites. So IoT NTN can communicate with both of those satellites. The specific module we announced today is a GEO compatible satellite. It supports, this is part of the standard, band 23, 255 and 256.
So when it comes to IoT devices, we all know that they're based on, well, they're usually based on sort of low power, low energy consumption devices. How do you work around the problem with working with satellites? Because the vast distances involved means that there's a lot of energy needed to get a signal from one place to another. So how is it that is this something your module is sort of able to provide engineers? This is sort of solving the energy issue?
Yeah, of course, LTE-M and NB-IoT are both very low power standards for cellular networks specifically developed for IoT applications. Now, I will say when you compare it to kind of legacy satellite connectivity options that you had out there, power consumption, if you're connected to satellite, is a lot lower. However, it is higher than what you would compare if you were on an NB-IoT network, just connected through cellular.
Right. And so what kind of energies are we talking about when it comes to satellite communication with IoT devices?
Yeah, that's a question that's really difficult to answer, to be honest, because it really depends on the use case. It depends how much data you're sending, how often you're sending it. It also depends on, like for GEO satellites, you pretty much can always count on, is there a satellite there that you can connect to? But with LEO, the constellation also is important. The constellation size is important to consider. So that all influences how long the device has to stay on. So it's quite difficult to just give a generic answer.
And so I can imagine if you've got an IoT asset tracker that's going to go anywhere in the world, one of the geostationary satellites would be the best one to use. A very tiny packet, only has to talk once an hour or so, sends the packet and forgets, but it can be basically seen anywhere around the world. But if you need something that's a bit more, say like more data dense, it's probably better to go for the low Earth orbit. Would that be correct?
I don't think you can say that on also on a kind of standard basis because low Earth orbit constellations, a lot of the constellations are still being built out. So if you're looking at different operators that have satellites in the sky for LEO constellations, many of them only have a few satellites currently up there. And that kind of influences what your connectivity,
right. So
what your connectivity looks like.
So this is a really interesting question because I've always wondered how the relationship works between those who produce modules and devices to communicate with satellites and those who actually make the satellites. So for example, and this could be completely wrong, so this is more of a question than a statement. I'm imagining that companies like Starlink, when they put their low Earth orbits in low Earth orbit satellites in orbit, they don't bring them out to the rest of the public. It tends to be a bit closed. Is that correct?
Well, Starlink has announced something called direct-to-cell, and this is a different concept from IoT NTN. So Starlink, the assumption is essentially you can take an unmodified cellular device and connect it to the satellite. So the satellite actually becomes the base station in the sky. And the modifications are happening on the satellite side. So what Starlink has focused on so far, at least, are a little bit higher data speeds, LTE Cat 1 and higher, essentially. So it's a different use case maybe than IoT NTN, which is really focusing more on those, LTE, NB-IoT, low power, wide area technologies.
And so, so like you're saying that the satellites that for example, Starlink produces, they're not really geared towards those IoT markets, and so those who develop IoT products need to sort of wait for more established satellites that are dedicated for that task.
Well, so Starlink has announced connectivity for cellular devices. They have some partners around mobile network operators. And there are, I believe on their website, there are plans to expand that into IoT devices for next year. So they have plans around that. But again, it is higher data speed, so the use cases are most likely going to be a little bit different that would find that kind of data rate attractive.
And so when it comes to the u-blox module that you've released today, the one which enables satellite communication, I take it that can't communicate with Starlink satellites in that same way because they need their own hardware, their own protocols and stuff. So the ones that you can communicate with, are you saying that those satellites themselves, the ones that are being designed for the u-blox system, they are still in development or they're still kind of being deployed because there aren't too many currently in active service?
Well, the SARA S528 NM10 that we announced today actually communicates with GEO satellites, and because of their higher altitude,
they can,
this issue of building out constellations, right, is not really an issue. This was, prioritization for us internally. Where do we focus on first? And so we opted for GEO because of the coverage a single GEO satellite can provide.
Which makes complete sense, because you can be anywhere in the world, you'll still see the satellite, which makes complete sense.
Correct.
So what kind of applications are you hoping to put this new module into?
Yeah, so we see a lot of interest from applications that tend to be in areas maybe where sometimes there's cellular coverage and they can be on the cellular network, but where a device or a thing essentially in the IoT might travel sometimes outside of cellular range. Other applications we see interest from are also things where you might have part of your installation in an area with good cellular coverage and another part in areas where there is no cellular coverage, but you want to just deploy one item, one SKU in those different areas. So just some examples are renewable energy. So for example, if you have a solar plant or a wind farm or something, many of those are in areas that have cellular coverage, but you might have maybe 20% of sites that are outside of cellular coverage. And so that allows you, from a logistics perspective, it's just one item. You don't have to consider, I need to order this much of this and put it over here, and then this much of that to put it over there. So you're able to really simplify your logistics. And then other examples of moving assets are things in asset tracking, also in agriculture, where you might have assets or maybe cattle or animal herds of some kind that are often maybe in cellular range or on the edge of cellular range, and then travel to areas where there is no cellular. And so that means essentially you don't lose connection. You still know the condition of your items, of whatever you want to measure essentially, and you have that data available.
Now, a major advantage I can see here is because it's obviously it provides a dynamic connection option whereby it will always hop onto whatever's available first, kind of like, if cellular's there, go to cellular. If it's not there, go satellite. I'm also guessing that's going to make designs quite cost effective for engineers, because it means that, because I don't know the facts behind this, but I'm guessing that satellite connections are probably more expensive than a typical cellular connection. And if that's the case, you can kind of minimize the cost of connectivity.
Yeah, that's true, and that's what a lot of our customers are interested in. I also would like to say maybe that one of the things that's really great about the IoT NTN standard from just a hardware perspective is that it's really a relatively minimal change to a cellular device's hardware, software, and so on. You have to support a few additional bands. There are some RF changes, some things like that you need to do. But if you're looking at the cost adder, it's relatively minimal if you're comparing it to a LTE-M device, for example, with a similar feature set, of course.
And keeping in mind that an older device would have to have an LTE module and a satellite module, but you're basically putting those into one package, which not only simplifies the design, helps to minimize the BOM, which is another important one as well. And then, of course, you've got the option for connectivity between different bands, which again further helps to reduce the cost, because you can use satellite only when essential.
Yes, it's much more integrated than kind of legacy designs that often require two separate modules. It's a lot more space. So when you're thinking about things like animal tracking, for example, as well, size is important there. In addition, the Sera S528, the M10 part of the name is our u-blox M10 platform. So we include a full GNSS module in there as well.
But it's quite funny because right now I'm actually based in the Philippines, and I can see plenty of sort of edge cases where these kind of modules would be absolutely fantastic. You go to one area where my parents live, for example, and it got great cellular connection. You go down the road, it's completely gone. And obviously you wouldn't be using this in a mobile device because you need the high, because you don't need high bandwidth. But let's say you had an IoT device, maybe something like a portable sensor, environmental sensor, or maybe some kind of asset tracker in a vehicle. Half the places here don't have the proper connectivity, and so it would be great if you had a module that can just sort of switch to different bands as needed to make sure that you're always connected. So what other areas could you see this device being used in besides IoT and sort of like asset tracking?
Well, so other areas where we're seeing interest are some areas in automotive for vehicles or fleet management as well. Now, in some of these cases, many of these vehicles might actually never leave cellular range. However, the cost adder of having satellite kind of as a backup function in the vehicle is valuable enough for those. Maybe in some cases it might be 2% of of the time that somebody might actually have an issue outside of cellular range. It's the cost adder is limited enough that is of interest to vehicle manufacturers. So that's, I think, another area. And then maybe another one we haven't covered yet is first responders or kind of backhaul activities for business continuity in case of a natural disaster. So these might be use cases where you have a cellular predominantly, but you don't lose connection in case of an earthquake or a flood or something.
And again,
like that.
that would be perfect for the Philippines because of the fact they get typhoons, power gets knocked out, cellular stops.
Exactly.
It's a serious problem, and it's actually one of the reasons why I personally got Starlink installed where my parents live, because of the fact that if there is a typhoon, they're going to lose connection, and it's important to have that constant connectivity. So again, it makes sense for it to be used in sort of remote and areas which, like you say, are subjected to natural disaster. I think one application I could also think of is maybe something like 4x4 trucks. So if they go off-roading, for example, and you get stuck or something happens, because you've got the asset tracker that can always be connected, you can always send a message with your GPS coordinates, and someone knows exactly where you are.
Correct. They know your location in case of emergency.
And I take it this would also work in marine applications as well.
Yes, it does. I mean, it works in any area where satellite has coverage. It could be the open ocean as well.
So,
yes.
so as long as you can see the sky, you're pretty much covered.
Yeah, as long as, again, their satellite needs to be in your, the constellation needs to be able to see where you are on the ground, which is quite simple with geo constellations because of their high altitude.
Because it's always there.
One satellite sees about 1/3 of Earth, so you don't need that many. With LEO, at the moment, until constellations are maybe a little bit further built out, what you'll see is a smaller part of Earth. So in these cases, you might have to wait a little bit for a satellite to come into view, and then that satellite can relay the signal.
Or the satellite provider has to spend billions on putting in 200,000 satellites for it to get constant coverage, like we're seeing with some other providers at the moment. Because I think,
yeah, I mean,
you're going, sorry, carry on.
Yeah, for I think IoT NTN applications, the numbers I hear are not as high as they are for some of the consumer broadband type applications. So I think the data that's being sent is less. The latency requirements are usually not as stringent. So you can get pretty good coverage with many fewer satellites.
And I also suspect that those kind of satellites, they can also afford to be bigger, larger, which means that they can have more transceivers on there, so they can handle more connections simultaneously. And so compared to something like Starlink, where you have to have 50 million satellites all communicating with each other, and each one costs a fortune to launch. Because personally, one of my biggest concerns is the economics behind it. So it kind of makes sense, whereas your standard LEOs, the ones that are further out, they make kind of more sense for IoT. And so do you envision this kind of module being used in most IoT products, or do you see this being more of an edge case device?
No, I think we're expecting really quite a lot of growth here because, again, the cost adder is not that significant. And what this really allows you to do is to think of satellite connectivity as a feature. It's not a standalone module, not a standalone device. It's a standalone SKU that somebody has to put a lot of effort behind. So over time, I think the economies of scale will also grow. So we're expecting to see quite a lot of uptake for satellite connectivity.
And I think it's really nice to see that as a feature, as opposed to it's almost like a software feature instead of a hardware feature, because it means that the engineer doesn't have to go, here are 5 modules to make this thing work. I can just get the one module and it'll have everything I need on it. And I think that's really exciting. But I have a question about the sort of the more technical side, which is in terms of the antennas. So, do you need to have separate antenna for for these different things, or is it all under one antenna?
So when you compare it, so this is also another, I think, important differentiator when you're thinking about those kind of legacy satellite devices where you had one module for cellular, one module for satellite, and then you had to integrate those. Some of these antenna requirements were, quite specific. Expensive, very large antennas, and so on. So with IoT NTN, you might not want to get the cheapest cellular antenna out there, maybe a little bit higher performing one, but a standard cellular antenna actually will provide enough sensitivity for proper satellite connectivity.
Oh, blimey! So you can have. So it's possible to have just one antenna for both.
Yes.
So the idea of having one antenna for this design with multiple different things, different connectivity options, means that it becomes cheaper in the hardware as well. Of course, you have to spend a bit. Maybe you might have to spend a bit more on the antenna to make sure it's a good quality one for the high degree of sensitivity needed. But still, that's a fantastic option for engineers.
Yeah, so you can use one antenna that's both satellite IoT NTN plus LTE, essentially.
So when it comes to using the antenna, is it sort of like LTE works, then satellite, or can you use both at the same time?
Well, I mean, the use cases are generally connected to one network or the other. So think about it similar to roaming. When you travel to another country, you eventually will lose connection to your home mobile network operator and roam onto another network. And this is essentially similar how it will work for satellite connectivity. When you reach the cellular edge, essentially, your device will switch over to satellite and then connect to that network.
So, and I've always loved to see new u-blox products come out, because they've always got something great in the next modules. And personally, my friend's always looking for the latest ones that come out before the public even knows. He's got people he knows inside the company to sort of like, what module's coming next, because I need to know what we can use in our next products. But looking sort of towards the next 10 years, where do you see u-blox going with this kind of connectivity option?
I mean, I think you will see more satellite-capable products from us. This is the first one, but again, this is connectivity for GEO satellites. I think we are evaluating also connectivity to LEO satellite constellations. We do also have an integrated module, meaning not two standalone cellular plus sat, but we have an integrated module for proprietary systems in a partnership with Orbcomm. So I think you'll see us engage more in this space and see more products coming out.
With regards to the new module, what would you say you are most excited for in terms of what application you want to see it in?
Well, I think we have, there's been IoT has grown so much over the last 10 years or so. And I think there has always been an interest in providing better connectivity in areas that outside of typical cellular range. It's just been cost prohibitive for many applications, right? I mean, satellite connectivity has been around for many years, but it was very expensive. It was a dedicated device. And so really only your most highest value assets, your most critical communication was connected to satellite. That did not mean, though, that other applications did not have an interest in, not losing connectivity outside of cellular range. It was just, it didn't make sense for their business case. So we are excited about the opportunity for much greater access for a broader range of applications through satellite technology.
And I think it's also really cool to see that this u-blox module is one of the, would you say it's one of the market's first combined LTE and satellite offerings out there?
There are some other IoT NTN modules out there already. I think something that is unique about the Sierra S528 is that we have an integrated, full integrated GNSS chipset. That's our u-blox M10 platform. So that's standard precision GNSS. This platform is really well known for low power consumption and its small size, which of course means we could fit it in the Sierra form factor. And I think what's unique about the Sierra S528 is that we actually have two different antenna pathways. So you have the LTE/satellite antenna, and then you have a dedicated GNSS antenna as well. And what that means is you can send data and location at the same time, essentially.
I was about to say, and that actually means that the module is almost an asset tracker in its own right. You almost need nothing else to make it work, which again further reduces the BOM.
I mean, it's quite integrated, and I think what also having the integrated GNSS allows, in addition to obviously having location there already, is that when you have like an on-off scenario, you're actually saving power as well, because you have you're able to send data as well as location at the same time, so the device can go on, you send, and then you turn off. Versus in other use cases where there's often a shared antenna, you have to do it sequentially. So that means the device has to stay on for longer.
So just before we wrap up this podcast, I've got one more question for you, which is that for the engineers who are watching this video, if they want to get involved with u-blox solutions, including this new module, what would you recommend that they do?
So they can go to our website. There is an area there where they can fill out a form and express their interest. And then somebody from u-blox that's in their region will get back to them.
Well, all I can say is thank you ever so much for taking the time to see us today on this podcast. It's been an absolute pleasure.
Thank you for having me.
No worries. Thank you ever so much. If you like the content that we do here at Electropages and want to show your support, then consider hitting the like button, subscribe button, and the alert notification. And if you want to see the latest news and articles in the electronics field, then head over to our official site at electropages.com.